Analog and digital transducer. Analog transducer. This transducer converts the input quantity, that is our physical or mechanical quantity, into an analog output, which is a continuous function of time. Generally, our analog output or analog signal are continuous function of time. Thus, a strain gauge, an LVDT, a thermocouple or a thermistor can be called as analog transducer, as they give an output which is a continuous function of time. Our next type of transducer is digital transducer. These transducers convert the input quantity into an electrical output, which is in digital signal, which is in the form of pulses, and its output is represented by 0 or 1. The digital signal is represented by two letters, that is 0 and 1. Transducer and inverse transducer. As we know that the work of transducer is to convert one form of energy into another form. So the transducer will convert the physical or mechanical energy into electrical energy. But when it is converting the electrical energy into mechanical or physical energy, then that is known as inverse transducer. A piezoelectric crystal acts as an inverse transducer because when a voltage is applied across the surface, it changes its dimension, causing a mechanical displacement. Means the voltage or the electrical input will be converted into mechanical output. Comparison between a sensor and a transducer. So, we will discuss a difference between sensor and transducer. First one is according to working principle. Sensor senses a physical measurement and makes it readable for the user, but it keeps it in the same format. Means, if the measured quantity is a physical or mechanical quantity, then we will get an output in physical or mechanical quantity. But in transducer, the senses the physical measurement and convert it from one form of energy to another form. That is, non-electrical quantity means our physical or mechanical quantity into electrical quantity. Means transducer will convert one form of energy to another form, but sensor will not do that. Then examples of sensor: thermistor, motion sensor, pressure switch, etc. are sensor. But microphone, pressure transducer, linear transducer are example of transducer. Then uses and application. Patient monitoring, infrared toilet flushes, liquid dispensing in drinks machines, etc. are sensor. HVAC monitoring, engine control, steering system, ramp and bridge lifting system are application of transducer. So we will discuss about the sensor one by one. First one is our displacement and position sensor. So displacement sensors are basically used for the measurement of movement of an object. Means suppose one object is there, previously it is present in some position. Then due to any force, suppose any external force, it is displaced to another place. Suppose 5 meter from the previous place. So this 5 meter distance means the distance between the previous position and the final position is our displacement. That will be measured by sensor. Then that is known as our displacement sensor. Then position sensor means it will tell us about a particular position or location of a object with reference to some elements. Or suppose like that our coordinate system. how we are representing suppose any points in a coordinate system. So like that the reference point is there, our origin. Then proximity sensor. Proximity sensors are a type of position sensor and are used to trace when an object has moved within particular critical distance of a transducer. Means tracing devices or tracking devices are our proximity sensor. One by one we will discuss that. First one is our potentiometer sensor. I will show you one figure in this and which will show you the construction of potentiometer sensor. Here you will see one rotary type of potentiometer sensor employed to measure the linear displacement. The potentiometer can be of linear or angular type. If the potentiometer is measuring linear displacement, then that is known as linear type. If it is measuring angular displacement, then that is known as angular type. It works on the principle of conversion of mechanical displacement into an electrical signal. The sensor has a resistive element and a sliding contact, or that is also known as wiper. The slider moves along this conductive body, acting as a movable electric contact. Here we can see the schematic diagram of potentiometer, and we can see the parts of the potentiometer. First we can see a resistive strip and a wiper. This wiper will slide on the resistive strip. Then we can see the potentiometer, and beyond that we can see one spring, that is our coil spring, and at last we are having one drum that is wounded with thread or threaded drum, and the last part of the thread will be connected to the object which displacement to be measured. The object whose displacement is to be measured is connected to the slider by using a rotary shaft for angular displacement. If we are measuring the angular displacement of the object, then we have to use one rotary shaft. If we are measuring the linear displacement, we have to use one moving rod. And we will use one cable that is kept straight during operation. The resistive element is a wire, wound track or conductive plastic. The track comprises of large number of closely packed turns or resistive wire, which we can see in the diagram. That is our threaded drum. Next, conductive plastic is made up of plastic resin embedded with the carbon powder. Means the conductive plastic contains carbon. Wire wound track has a resolution of order that is plus or minus 0.01%, while the conductive plastic may have the resolution of about 0.1 micrometer. During the sensing operation, a voltage Vs is applied across the resistive element. That is our applied voltage or input current. Then a voltage divider circuit is formed when the slider comes into contact with the wire. Whenever the wiper is coming in contact with the resistive wire, then a voltage divider circuit will be formed, which we will see. The output voltage VA or VO is measured as shown in the figure below. I will show you that figure. The output voltage is proportional to the displacement of the slider over the wire. Then the output parameter displacement is calibrated against the output voltage VA. Then application of potentiometer. The sensors are primarily used in the control system with a feedback loop to ensure that the moving member or component reaches its command position. These are typically used on machine too to controls, like our lathe machine or shaper machine. We have to control the speed of the tool or the position of the tool. That thing can be done by the potentiometer, with the help of potentiometer. Then we can use potentiometer in elevators, liquid level assemblies, forklift trucks, automobile throttle controls, etc. Then in manufacturing, these are used in control of injection molding machine, woodworking machine, printing machine, spraying machine, robotics, etc. These are also used in computer control monitoring of sports equipment. The next type of sensor is strain gauge. The strain gauge is an element, is a ratio of change in length to the direction of applied load to the original length of an element. We know that what is strain previously also. That is, we are telling strain epsilon, we are denoting strain by epsilon, which is equal to change in dimension by the original dimension. But when the dimension will change, when the dimension of any element will change, whenever you will apply some force on any element or object, then due to the stress generated, the dimension is changing. So here we will use that. The strain changes here with the change in resistance of the element. So we have one relation for that, that is del R by R is directly proportional to epsilon. Means del R is the change in resistance, R is the original resistance, and epsilon is the strain. So whenever you will convert this proportionality symbol into equal to symbol, then we have to multiply one constant with this. So that is del R by R equal to G into epsilon, where G is a proportionality constant, which is gauge factor. In general, the value of gauge factor G is 2 to 4 for a resistance taken up to 100 ohm. Resistance strain gauge follows the principle of change in resistance as per the equation, whatever you have seen previously. It comprises of a pattern of resistive foil arranged as shown in the figure. I will show you that. These foils are made up of constantan alloy, that is constantan alloy consisting of copper and nickel, that is copper 55% and nickel 45%, and are bonded to a backing material, plastic, that is polyamide or epoxy or glass fiber reinforced epoxy. The strain gauges are secured to the workpiece by using epoxy or cyanoacrylate cement instrument.